Okay, so now let's get started, and maybe you would like to know who we are and why we're here. So, my name is Damiano Bolzoni. The try was nice anyway, thanks. And he's Christiaan. I also cannot pronounce his surname. It's 5 years I'm living in the Netherlands. I still cannot make it in Schade.
Yeah, almost.
Yeah, almost, okay. I was once a PhD student. I graduated last year with a thesis about anomaly-based intrusion detection system. I'm now a postdoc, and I have also a spin-off from the university where I did my PhD. So basically this means that I don't do any more fun stuff. It's all about project, money, and supervising other PhD. So that's what I'm doing. I have a PhD basically working in the business of critical infrastructure. So you might wonder why I'm here, because there is no match yet with malware. So it's my hobby so far. Okay, so this is our first attempt to deliver a malware talk. About Christiaan, is a bachelor student in mechanical engineering. He has been really active in gaming anti-cheating development for years. So yeah, he's also not really, from his bio you would say, why he's also here? Well, he's really talented. He was doing the operating system course under my supervision, and that's how we got in contact. And the guy is really pretty much good at hacking the Windows kernel. So that's basically how we got together. Today, what you're going to see, well, it's let's walk through it quickly. Well, we will tell something about malware, internals, and we will also have an outlook of the current analysis tools. I think that upstairs you have seen everything, because this year it's all about malware analysis. So each vendor has a malware analysis tool. Then we will talk about our idea, and we will show you what we call the avatar, and then we will have a demo and some conclusion. So, well, you know that malware has become basically a business. People make money out of it. With botnets, for instance, they want to grab financial information about people, username, password that they will be later sold or reused in some ways, and this basically makes it the most urgent problem to address in the cyber world. And it's a big problem because there are a lot of them. So Symantec and their friends are showing every 6 months impressive growing statistics. And this is mainly due to 3 factors, I would say. So the first factor is they use polymorphism. So basically the same sample is just a little bit changed somehow in its content, but not in its functionality. Therefore, you have to develop a new signature for that thing. They use the different packers, so you have every time that you are analyzing a sample, there will be something different in the way it starts. And I would also say that basically malware writers are just better, so they just can kick the ass of the big guys upstairs. So let's say if we look at the way the malware works, in the past, you had this monolithic executable, which means that the malware writer was shipping everything already in the thing you were downloaded or taking from a USB stick or whatever, receiving by email. But this was making it difficult the same way it makes it difficult for normal software, because it's difficult to adapt to OS versionings, because for instance right now Windows 7, if you use the 32 bits, you can do different things from the 64 bits. And it was just easier for an antivirus to spot it, a big thing of 1 megabyte, for instance. There were so much code that could have been detected while running the analysis so the malware writers basically did what the rest of the world was doing. They just switched it to plugins. So right now there are reports that basically rate that 30% of the malware is downloading additional components while you started. So you receive, let's say, a spore, that is responsible to make the malware persistent on your machine. And this spore, which is usually maximum 50 kilobytes, 100 kilobytes in really, really few cases. And so the spore is just, the moment it goes alive, it just pulled down from the network, so from the internet, additional components. So password grabbers, stuff to infect other executables, so to be even more persistent, and so on. So for instance, botnets are this classical example, because you want the botnet to be able to cope with the future, right? So you don't know what you want to do in 3 months. Maybe today you only wanted to sniff password. You only wanted to sniff password, and tomorrow maybe you also want to grab credit card numbers. So you must have a kind of flexible system, the same way as regular software. And let's now have a look at what we have so far to basically defend. So I guess 3 or 4 years ago, we started building, well, they started building dynamic malware analysis tools. So a dynamic malware analysis tools is simply a virtual machine or a bugger system, and actually a very highly instrumented system where you can basically execute the malware in a controlled environment. Whatever the malware will do, it will be logged. So you can see which registry keys have been changed, which file have been created, which files have been altered, whatever, a memory dump of the malware, and so on. So because of course, if we recap the very first slide, we say that we have a lot of samples which are basically the same. They come from the same original sample. And so some researchers have developed what they call the clustering, which is basically a function to say, well, this malware is actually, it belongs to a family of that we very well know the behavior of. Okay? So we're using certain properties, I don't know, the files that are created, the way these files are created, to classify malwares into clusters. There are several of these tools. Some are commercial, like the CW Sandbox, which was before a research project. We have Anubis, Malware, Malnet. They all do kind of the same thing. They are different because one uses a virtual machine, the other one, one uses VMware, the other one uses Kimu, but they all do kind of the same thing. And if we look, so this is for the analysis part. When we want to discover what the malware does, that's what we will use. And then it comes the defensive part, because once you know what the malware does, you also want to stop it. And so apart from the regular signatures, that is basically a flawed model, because one day you will be asked to download maybe 5 gigabytes, or if you're already not downloading today, 5 gigabytes database of signatures, so it's simply going to explode. So they come out with the brilliant idea of creating model-based antivirus software, which is basically using the clustering information to say, well, I don't know exactly this sample, but because it really resembles this very well-known family of malware, I know it's malware. And you use basically the output of the dynamic malware analysis tools to create these models. Now, where are basically, where we come in the picture? So if you look at these DMA tools, they have some problems, as usual. Well, the malware writers are just becoming smarter. So, because malware writers know about these tools, they have implemented several countermeasures that are used to avoid the analysis or to slow down the analysis, because, for instance, the malware runs only if a user is logged in. So, of course, in an automatic process like the one from these tools, there is no user, right? So the malware is simply not starting up. Or, before it activates, it will just wait for a random number of seconds or minutes. So instead of starting right away, it will just freeze and wait 20 minutes, 25 minutes. This is also a problem because if you are receiving something like 10,000 samples per day, you have to run them at the fastest. Yeah, you have to process them really quickly. And if every time you have to wait 20 seconds before you can actually analyze that malware sample, it's just going to take forever. Then there are the very easy checks. So the first one were about virtualization. So the malware checks that it's actually virtualized. Checks for known registry keys, like these latest two checks were the one that were used against Anubis. I don't know if you know about it. It's a research project from the ISEC lab. And also they start because Anubis is, I'm talking about Anubis because it's the one that you very well know the internals being a research project. Anubis was using some fixed IP addresses to connect to the internet. So basically the malware was checking, if my IP address is this one, then I know I'm inside Anubis. So basically the problem here, the problem that you have in this situation is that you don't know the context. The malware, when it's actually executed on a real host, has a different context than the one that you have into the DMA tool. And it's difficult to replicate it beforehand, because it's the usual problem. The attacker just needs to find one weak spot of yours, while you have to prepare for all the possibilities. So if tomorrow they find out a new way to avoid the analysis, we have to start everything from scratch once more. Okay, then there is another problem. If you're using a tool to analyze malware, it means you're usually doing this post-mortem. It means you already detect that something went wrong, and you want to be sure that that little thing is really malware, so you submit the sample and you get a report back. So you cannot really protect your host in real time because the infection has already happened. Right? You can clean up, but maybe this happened actually a week after the malware first went live. And by the way, yes, if you submit a sample, you already suspect it's malware and your antivirus did not detect it. Otherwise, it would have already been killed on the way. So there is no real-time protection with this thing. And you need special instrumentation and a lot of money to buy this instrumentation to run the analysis. Okay? There is just a side note. If you go upstairs, there are a couple of vendors which claim, but I'm pretty much sure that they do that they also run a local analysis. So they have incorporated a kind of dynamic malware analysis tool into their antivirus, so that you run the analysis locally. Problem is, you still have to deploy that solution on each host. And the malware, in theory, could spot it, even if it is a kernel driver, right? So we still have the problem that you find you try to patch, and you still have, they will just need to find out a new way, and you again have to start from scratch. So we were wondering, so we were not really, in the sense, we were not into this business. So we were overlooking at it, and we wonder, is it possible to use this dynamic malware analysis tool on the fly? So let's say without having to run the post-mortem analysis, without having to deploy the software beforehand on the host that I want to monitor. I come from intrusion detection, so my idea is to doing real time, right? In particular, in my original world, in the IDS, they have network operation centers where they do real-time monitoring, or at least they hope they can do real-time monitoring. This basically means, can we create a NOC for malware? Can we have the same thing we have for IDS? So the idea is the following. It's kind of crazy. It came out while working on something that could resemble a honeypot, but is not exactly a honeypot. And we call it Avatar. And you will be, it's clear why it's called the Avatar. You just need to go through the third bullet. So, because we have these additional downloads that have to be performed by malware, you need some extra content providers, right? So it's a web server that has been early compromised, and